Hello, everybody. Welcome to the meetup. Looking forward to the technically, actually, the last one of the summer, because when we do the next one, it will technically be fall. Whether it will feel like fall, we will find out. But for now, it will at least technically be fall. So everyone's had a great August so far. We only have a few days left in the month, even. And I hope everyone's really excited as we do this. So first things first, like we always do when we have the meetup in person, I usually ask who is hiring. Now, I know not everyone can jump in and say who's hiring. In fact, no one can actually say it on camera except for me. And I am hiring for mainly part-time roles, some full-time roles, but data scientists, Linux admins, salespeople, a little bit of everything. That's what I'm hiring. But if you're hiring and you're not on camera, let us know by going to the NYHackR Slack in the job postings channel. If you don't have the NYHackR Slack, you can find it at nyhackr.org. And at the very top, there's like a little jumping hashtag. It's like actually jumping up and down a little bit. That hashtag takes you to the Slack. And once you're in there, you can then post your jobs in the job postings channel. Another thing that we can't all do together, unfortunately, is eat pizza together. Now, I got my pizza this month from a place called Zazzy's. It's sort of like a cross between like a Neapolitan place and a New York corner slice joint. It's a fun combo. Here's the front. We got good cheese lock. You can see the charring on the bottom. So hope everyone else is enjoying their pizza or their other food that they got. I know we can't be enjoying this together, but next month we will be both in person and virtual, and at least the in-person attendees can enjoy. For everyone in their virtual land right now, hop into the chat, either right here in Zoom or in NYHackR, and let us know what you are eating if you're eating anything, and I certainly hope you are. Speaking of chatting and slacking, because we can't ask questions directly of the speaker because most people can't be on camera, if you have a question, please go to the NYHackR Slack, which you can find at nyhackr.org, and there is a channel called Monthly Meetup Chats. Go in there and ask questions. I'm sure some of you will ask questions right here on Zoom. Whether I get them on Zoom or NYHackR, at the end of the talk, I will collate them and ask the questions of our speaker. I do prefer Slack though, because for whatever reason, I can't copy and paste out of the Zoom chat, and I need to be able to keep a running list of these. So please, please, please ask it in Slack if at all possible. We have an exciting few months coming up. We have the September meetup will be September 27th, both in person and virtual. Thank you to Microsoft for hosting us there. It will be Eli Miller, and the talk is going to be about predicting the Taylor Swift Eras Tour set list. Every concert, she has a few, I think 3 songs that are chosen differently for that particular show. And Eli will talk about how he's going to predict that. That'll be really fun. It is in a smaller room at the Microsoft office, so space will be limited. We will officially put that up for RSVP soon, but RSVP as soon as you can, because it will be first come, first serve. We are going to have to limit the space for this one. October, we will have a meetup to be announced a little bit later, but we also have the R in Government Conference. You'll see I'm actually wearing the shirt right now. These shirts make up a large portion of my wardrobe, let's be honest here. That takes place October 18th through 20th. We'll have a day of workshops on the 18th and the conference itself on the 19th and 20th. If you're a member of this meetup, which you are since you're here, you can get a 20% discount with code NYHackR. And we will be giving away 2 free tickets to the conference, either in person or virtual, your choice, after the talk. If you want to get the tickets, you go to rstats.ai/gov, and you can find tickets there. And I see Nicole just posted that in the Zoom chat and in the NYHackR Slack. So we have an exciting few months coming up. Beyond October, we have some speakers lined up, but we don't necessarily have space lined up. So if you'd like to speak, we can find you a month. Let me know you'd like to speak, or I'll have to volunteer you. If you have space somewhere in the city and would like to host the meetup, let us know. We have a few good hosts in Microsoft, in Two Sigma, in BrainStation, and a few other spots, but we always need more because it's very hard to find space. So if you have space available and you'd like to have a few dozen data science nerds in your space, let us know, because we're always looking for a nice roster of places to go to. So remember, jobs, chat in the Slack, and the conference coming up. So with that, I am very excited to introduce our next speaker coming to us from the UK. So one of our long distance speakers, once again, here to talk to us about Arrow, which I think many of us at least are very excited about. Everyone, please welcome Nick with emoji applause.
Okay, yeah, so efficiently engineering bigger data with Arrow. Let's go. Okay, so today I'm going to be talking to you about a few different things. Firstly, working with larger than memory data in R with Arrow. Then I'm going to be talking to you about using the dplyr API with Arrow and some tips and tricks that can help make workflows just a lot easier when doing this kind of thing. I'm going to be talking to you about the Parquet file format and how that can help you really get better performance on bigger data sets. And then I'm going to go on to talk about dataset partitioning. Okay, but before I go into that, I've used this phrase larger than memory data, but I wanted to get an idea of what does this mean, larger than memory? Okay, so I think probably most of us that have tried playing around with bigger data sets in R, sometimes you can load that entire data set into your R session and just crash it entirely. And that's all to do with if the data set is bigger than the RAM on your machine. So I wanted to get an idea of how much RAM on average does a computer have. It was kind of tricky to find this, but I found a bit of data on the Steam website. This is going to be skewed, right? Because Steam's where you can get, where people get games from and things like that. So people might have higher specs. But we can kind of conclude from this, and typically, your average laptop has 16 gigabytes or less than that of RAM. Okay. So I'm going to show you an example of working with one of these larger than memory data sets with Arrow. So the data that I'm going to be using in this example is from the New York City taxi data set. It's a data set full of information about taxi rides in New York. The full data set goes all the way back to 2009. And it's got data about things like how much was a taxi fare, how many people were in the taxi at the time, what was the pickup and drop-off location, and things like that. This data is all available online. And if you want to get hold of it, you can either go to the site itself, the link's at the bottom there, or there's some code that will be in the slides. It's hosted on an S3 bucket, and you can download it with just a few lines of code. It's around 40 gigs in total. Okay. Now I'm going to come clean here. I kind of wussed out on doing a completely live demo. I did pre-record this, and that's only just because sometimes with Zoom on Linux, it does weird things with my CPU, but I will be narrating this demo. And I promise you, if you take the code and test it out yourself, you'll get very similar results. Okay. So let's work with a really, really big data set with Arrow to show you how it's done. Okay. So the first thing that I do then, I'm going to load the Arrow package. Okay. And I'm going to set up this data set. So I've created a variable called NYC taxi, and I'm using a function from Arrow called open data set. And I just point that at the path where the data is stored on disk. Okay. So the first thing that I want to do, let's have a look at the size of this data set. So how many rows of data are in it? So I'll run this, and it will take a moment because it's pretty sizable. Okay, so the results there, that is 1.15 billion rows of data. I will admit that before this, I've probably only worked with data sets in the kind of order of tens of millions. So this is pretty chunky. Okay, so with Arrow, we can actually use dplyr functions to analyze our data. So you don't have to learn a whole new API. So say if we want to answer the question then, what percentage of taxi rides each year had more than one passenger? So I'm going to take that NYC taxi object. So that's just the data set that I created. And then I'm going to group that by year. So again, if you're familiar with dplyr, hopefully this code should look kind of familiar with you because it's using that same API. So anyway, to answer that question, I'm going to start off by creating a variable called all trips, and that'll just count how many rows of data, how many taxi rides there were for that year. I'm going to create another column called shared trips. So that's going to be the total of taxi rides where the passenger count is greater than 1. And I'll chuck out any NA values because we've always got them in kind of these big live, real life data sets. Once I've done that, just to make it a little bit more visibly, kind of visually like simple on the screen, I'm going to create a new variable called %shared. And that is going to be calculated by just taking the number of shared trips, dividing by the total number of trips, times it by 100 to get a percentage. And then finally, call collect, and that'll pull that into memory rather than an arrow. So I'm also going to time this to see how long it takes to run this on this 1.15 billion rows of data. So the package tick-tock, it's quite nice actually. You just put tick above the code, tock below it, and then when you run that chunk of code together, it will time it. So let's have a look. So yeah, this will take a moment because it's quite a bit of data. Okay, so we've got the results. So we've got those summaries for all the different years of data in the percent shared column, and that took 6.077 seconds to run on all that data. Okay, so yeah, so that's running on quite a lot of data, managed to do it reasonably fast. And that's all to do with how kind of Arrow implements the dplyr API, but runs on the Arrow backend. So let's jump into a little bit about what is Arrow and a little bit about the background there, and then we can jump back into some more code examples. So if you go to the Arrow website, you'll see this description of Arrow. It's a multi-language toolbox for accelerated data interchange and in-memory processing. So that's quite a mouthful. So let's break that down and look at it like one bit at a time. Okay. So the first thing to know, I remember actually when I first started working on Arrow, I did find this confusing because people use Arrow to refer to the overall project, the specification and the R package, and these are all slightly different things. So we'll start from the specification. So Apache Arrow is a specification, and it defines how we represent table-like data sets in memory. Okay, so that's an important kind of starting point, how we think about that. It's just specifying exactly how to do this. And it's defined in multiple languages. So in this diagram here, we've got the specification itself for how we represent this data in memory. And then on that next row before, that's just showing that this specification has been implemented in lots of different languages. So we've got C++, JavaScript, and Rust on the diagram there, but there's loads of other implementations. So there's like C#, there's Java, and there's probably others that I'm not mentioning. But the one that we're really interested in for the purpose of kind of this talk and generally at the moment is the C++ implementation. And the R package, the Arrow R package, has created bindings for that. So what that means is you can use the Arrow C++ implementation directly from R, but without having to know any C++, and using the dplyr API for the most part to interact with that. And that C++ library, if you've heard of PyArrow, so that's the Python implementation of Arrow, that also creates bindings to that same C++ library, and the same for the Ruby implementation as well. So the idea behind Arrow is it's about accelerated data interchange. And a really important concept that I will come back to later is the idea that because we've got this standardized in-memory format, it prevents the need for what's called serialization and deserialization. So rather than if we've got some data, say in R, and then we want to work with it in Python, rather than having to copy it backwards and forwards in a format that both of those languages can understand, Arrow provides this implementation that both of those can understand. And serialization and deserialization, it's not necessarily a huge problem when you're working with smaller data sets, but when you're working with larger data sets, that can be really computationally expensive and take up a lot of resources. And that's what we're trying to avoid here. So there's a lot in terms of how Arrow works that basically allows it to do things faster. So traditionally, tabular data in the past has been represented in memory on a row basis. So each row of the data is kind of in adjacent bits of memory next to each other. And one of the features of Arrow is that it uses this thing called the columnar format. In other words, data in the same column is stored together. And that allows Arrow to take advantage of the way that modern hardware is designed to be able to speed up how kind of data is retrieved. So anyway, let's come back to the Arrow R package. So I guess this slide is just from the Arrow R package kind of README. So the question is, what can you do with the Arrow R package? So there's a few different things you can do. You can read and write data in a variety of formats. So we've got things like Parquet format. There's Arrow format. So you might have heard of this previously as Feather, and that's now been renamed as Arrow format. It can work with CSVs. It can also work with JSON. So that's kind of one area of functionality. It then also provides tooling for actually analyzing these data. So there's some bits of it that work for data that's been pulled in memory, but also data that isn't in memory, data that's stored on disk. And the Arrow package provides an implementation of the dplyr API. So we're not having to learn a whole load of new syntax to be able to work with Arrow. And there's also functionality. If you've got data stored on the cloud, so on S3 or Google Cloud Storage, you can work with that directly from Arrow. There's going to be implementation for Azure, but that's kind of still in the works at the moment. And there's some other bits and pieces as well, but we're not going to talk about those today. Okay. So I'm going to elaborate a little bit more about this idea of using the dplyr API in Arrow. So the dplyr package is designed in a way where the functions, the dplyr verbs, things like filter, mutate, group by, they've been written as S3 generic. So what that means is that they can work on one type of object, but they can also work on other types of object if methods are defined for this. So in other words, when you're working on a data frame or a tibble using dplyr, what happens is the dplyr API, so that's those functions, mutate, group by, etc., basically take that code and translate it into something that the dplyr backend can work on to analyze that data. Now, if you've used the package dbplyr, that works with SQL databases, but again, it's still using this dplyr API, so you can use those same functions, analyze data that's on a database, but without having to kind of work with SQL. And the dbplyr package basically translates from the dplyr API into something that SQL database can understand. And this is kind of how the Arrow package works. So again, it's taken that dplyr code, the R package translates that into something that the Arrow C++ implementation can understand and do all that work for you. Okay. So a really important concept when talking about kind of working with Arrow is the idea of data sets. So I think the best way to think of an Arrow data set is that it's similar to a database connection. So in other words, it knows where the data is, but when you set up an Arrow data set, nothing has been pulled into memory yet. And what happens is when you run a dplyr kind of pipeline, it only pulls things into memory when it needs to. And this is how we can work on this larger than memory data. So it uses this idea of lazy evaluation. In other words, it only runs the code to pull things in memory when it needs to. So if I was to look at that NYC taxi object that I created before, so it's an Arrow dataset object. If I was to take a look at the preview of it, it says it's a file system data set. It's made up of 122 Parquet files. And then it also prints out the column names and the data types of the different columns as well. Now, in terms of the dplyr pipeline that I set up before, so that was this code here, if I was to set that up without calling collect at the end and look at that object there, this is an Arrow dplyr query object. So kind of as I said before, this query is being constructed, but it's not been evaluated yet. Nothing's been pulled into memory, and it's only when you call collect, it pulls data into the R session. So what happens is all of these analyses can happen with the data, and it's only when we've got the subset that we want that we pull it back into the R session. So we don't overload and crash our R session with 40 gigs of data and 1 billion rows of it. So what I wanted to do now is talk about some tips for working with these large data sets, because I found, for me personally, I've got quite a specific workflow that I'll have when I'm working with dplyr, and I just need to modify it a little bit when I'm working with Arrow. So let's say I've got a task of, I want to convert the taxi fares in the data set to pounds, because that's the currency I work with. So I've got this little bit of Arrow dplyr code here, where I take my data set. I just want a couple of years of data. So I put a filter on there. And I think the last time I checked, this was the exchange rate. So to calculate the fair amount in pounds, I'm going to take the fair amount column and multiply it by 0.79. And then I'm just going to select the actual rows of data that I want to look at. So the first thing that I might want to do on this analysis is use the nrow function, just to see how many rows of data that I've got. So I'll do that here, and I find out I've got 139 million rows of data. So I may or may not want to pull that into my R session. So I find the most useful thing for me for working with these data sets is actually using the function head and then collect, just to preview those results and see the first few rows without pulling everything into memory at once. So first pounds, head, and then collect. Okay. So as I mentioned before, the Arrow package provides bindings to the dplyr verbs. And it also provides bindings to our functions. So if you want to use mutate in dplyr to create a new column, and then you want to use a function to create the values in that column, for that to work in Arrow, we have to have written the bindings for those. At the time of writing these slides, I think we had bindings for 37 dplyr verbs and 211 R functions. So some of those are base R, Some of those are string are, and some of those are lubridate. So that's all there in the docs. You can kind of skim through that list and see what's there. Okay. But actually, sometimes we need to think about like what happens when a binding doesn't exist. So we've got a lot of stuff implemented, but sometimes for various reasons, there are things that aren't there. So if I've got this example here where my task is to find the first 3 taxi rides in the data set in 2021, where the distance is greater than 100 miles. So I've created this variable, long ride 2021, and that is the taxi data set. I'm going to filter that I want the year 2021 and the trip distance greater than 100. And I'm just going to select the columns that I want to work with. Now, if I take that, something that I might do usually is, okay, I know there's this dplyr function called slice. So slice just returns a specific rows of the data. And I'm just going to say slice rows 1 to 3. And actually, if I run that, we get this error. So error in use method slice, no applicable method for slice applied to an object of class arrow dplyr query. So this is because slice is a tricky one. Not to go into too much, but basically in the internals of Arrow data sets, this idea of ordering doesn't quite work because Arrow is using different threads to read different bits of the data set. And so we can't quite have slice there. So what would I do here in this kind of analysis workflow? Head to the docs. So if you go to the docs, so it's like this page that I showed you before, you'll see what is and isn't implemented. And actually, the function slice head is implemented. So sometimes it is just a case of using a slightly different function, but that will get you pretty much, the same results for the task that you're trying to achieve. So I've run this code, and then we've got those first 3 rows. If we look at the error message, okay, it's not on that one actually. Another thing you can do is if you know that the results that you're going to pull back from Arrow aren't going to be too big for your R session, so you could use nrow as an example to see how many rows of data. An easier workaround then in that case will be then to call collect. So that will pull that data into your R session, and now you'll be working with a tibble at that point, and then you can use those dplyr functions. So there, I can use slice, and it gets us those results back. Okay. So as I said, there is a lot of the dplyr API that is implemented and is fine, but there is one little slightly different thing with what are known as window functions. So what are window functions? Window functions are calculations within groups. So I'm going to show you an example of something that isn't a window function, but then how that will become a window function, just because I think this is it's a slightly obscure bit of terminology, to be honest, but it is something that a lot of people do use a lot. So if I want to calculate the average taxi fare by year, say just for a couple of years, 2021 to 2022, then I could take that data set, filter by the years that I want to look at, select just those 2 columns, and then if I group that by year and then summarize that, so I create this variable mean fare, which is the average of the fare amount column, and collect that into memory, then that is absolutely no problem, and I've got that grouped summary. So that works without no problem at all. But what if instead of creating that summary, I actually wanted to append that to my original data set? So say if I wanted for every row of my data set to have the average taxi fare for that year as an extra column in my data set, then that's known as a window function. So that's something that isn't at present implemented in Arrow. So if I group by year and then use mutate to add that on as another column, I'll get this error, window functions not currently supported in Arrow. Okay, so we need to find a slightly different way of using these kind of functions. And this is where DuckDB can come in. So DuckDB is great. It's for working. It's kind of a SQL-based kind of database thing, and you can use it for working with kind of these large data sets in a similar way to Arrow. And there's overlap between DuckDB and Arrow functionality. So there's some things implemented in Arrow, not DuckDB, and some things implemented in DuckDB and not Arrow. And one of the great things about DuckDB is that it understands the Arrow format and it understands how to work with Arrow tables. And before I mentioned that one of the things that we can do with this Arrow format is, if implementation support it, be able to pass data between different things without having to serialize and deserialize that data. And that's how this works actually with a couple of functions in Arrow called toDuckDB and toArrow. So we can actually take that Arrow dplyr query that we've got, pass it over to DuckDB, run the code in DuckDB that isn't implemented in Arrow and then pass that back in Arrow without having to copy things back and forth. So here's an example of that previous bit of code using DuckDB. So it's exactly the same as before, but we've got two DuckDB. Then we call this mutate function. Then we've got to Arrow to pass it back to Arrow. And now that's worked and we've got the results. So we've got the rows of data, but with that mean threat on the end there. So that can be really helpful, I find. And there's a few other functions as well that aren't yet a thing in Arrow. So for example, if you're used to working with the tidyr functions pivot longer and pivot wider, you can also do this via DuckDB. Okay, so that was, I guess, a general overview of kind of dplyr workflows with Arrow. But actually, if we're thinking at a high level, if we've got really large data sets, what are the different things that we need to be thinking about to be able to work with them efficiently? I'd say like one of the top things in my list is Parquet format. Okay, so Parquet is a file format, and Parquet files are usually smaller than the equivalent CSV file. Parquet is a binary format. In other words, it's designed to be computer readable, not human readable. So you can't just open up Parquet files, say in Notepad or something like that, to look at them. But the advantages of the Parquet format is that there are a load of different optimizations that just make it so much actually faster than working with CSVs. So one of the things with Parquet is that it doesn't just store the data itself, it stores metadata about the data. So that's things like the data types. I'm sure we've all had issues or a lot of us at least have had issues where you've got a CSV file and you might load it into, I don't know, if you're working with Excel, I'm sorry, but you know, everything's a date, right? Because CSVs don't store the data types. So if something's reading a CSV file, it has to try to infer the data type, and we've got to hope it guesses it right. But with the Parquet file, it's got the data type stored with the data, so we don't have to deal with that problem. It also stores metadata about the data. So it can have things like how many rows are in that individual file. So with software like Arrow and other software, what that can do is then read the metadata rather than having to read in all the data to perform these calculations and know things about it. So that can be really useful for speeding things up. Parquet is also inherently column oriented. And it also has this concept of row chunking, which means that something reading a Parquet file can work on part of the file at once and skip some chunks. And that really can just really help things along. So rather than just kind of ramble at you about how cool Parquet is, I thought actually let's get a code example just to demonstrate the difference. So if we take that New York taxi data set from before, so that was a Parquet format data set. So what I've got in the code here, it's just right. I've written it to disk as a CSV data set. So it's the same data set, but in CSV format. So the first thing I want to think about is how much storage does it take up on disk? So if you remember from before, the Parquet data set, it was just under 40 gigabytes. So the function that I've got here, it just uses a few. Basically, this function just calculates the total file size of the files in a directory. So the total file size of the Parquet dataset is 37.5 gigabytes. But actually, the equivalent CSV dataset is 158 gigabytes. So it's absolutely huge stored on disk in comparison. There's a few different reasons for this. Parquet has different kind of encoding strategies built in. It's got some fairly clever things. So if you've got a value that's repeated a lot of times in a column, rather than repeating that value, it can just say, okay, this value, but like 100 times. And a few different things like that. There's also a difference in analysis speed. So if I was to take, so this is that same example from before where we wanted to basically count the percentage of taxi rides that had more than one passenger. So I timed this earlier. So in Parquet, I've got a slightly smaller subset than before. I ran that and that took 2.54 seconds to run that. So if I was to run the exact same analysis on the CSV dataset, how long do we think that will take? And the answer is 49.788 seconds. So again, the reason for this is there's a few different things going on here, but just the optimizations in Parquet make it just so much faster to run these complex analyses. So I wanted to give you an example of Parquet file metadata. This is from the Parquet docs. There's lots of stuff in here, and to be honest, like I don't kind of, there's lots of bits that aren't relevant, but we've got different things like kind of the number of rows and the schema of the data, so that's the column types and column names, and just lots of different things that then we can use to kind of optimize the reading of data. So the last kind of main topic around speeding things up that I wanted to talk to you about is partitioning. So when we've got these massive data sets, you could have all of the data stored in one huge file, and you could work with data like that. And that's, that might be just how you get the data, and that's fine. But one of the ways that you can speed things up is to use partitioning. So partitioning is when we store the data in multiple files in different directories, and we actually use directories representing columns in the data. So in the image here, we've got the NYC taxi data set, and I've just got a little bit of a preview there. So we've got a folder that's actually called year equals 2012. And then inside that, there's a folder for each of the months. So month equals 1, month equals 2, etc. And then inside each of these folders, then we've got the Parquet file. So that's just an extra kind of level of optimization where now, when we're doing analysis in Arrow, it can scan the different partitions and know we don't even need to bother with certain ones if we filter the data by certain variables. So again, I thought it'd be good to do some comparisons. A question that people often, I think, a reasonable question that people ask once they hear about the idea of partitioning, then it's, well, what variables in the data set should we use for partitioning? So I think one of the most straightforward bits of advice is to partition by data that you're going to use in your analysis. So I've set up this comparison. So the original NYC taxi data set, it was partitioned by both year and month. And I've created a copy of it that just partitions by year, but not by month. So let's compare performance on the two of those. So that's that same analysis as before. I've added an extra little bit here where we want to group the results by year and month, just so we're using both of those variables in our analysis. So if I run this code, this is again working out the percentage of shared trips. When the data set has been partitioned just by year, but not month. So in other words, we'll have to go into each of those individual files and just get the data for the month that we want. Okay, so that's taken 8.338 seconds. And then the original data set where we were partitioned by both year and month and not just year. Okay, so that's taken 5.6 seconds. So to be honest, those are both pretty fast, but on a bigger data set or one with less filtering, you'll get more kind of pronounced differences between the two of those. So partitioning can be a bit of a strange one. People have described it as an art and a science. And there's a few different things that I think are the most kind of useful bits of advice that I've been given on this. So the first thing to consider is the number of partitions is important. So, you could take it to a ridiculous level and say, well, what if I just have one row of data per file? And actually, that would slow things down because Arrow has to read the metadata of every single file. So that's going to add a bit of kind of overhead there. Generally, you should avoid files that are less than 20 megabytes or bigger than 2 gigabytes, and avoid more than 10,000 files because just life is not good at that point. But generally, partitioning on variables that you're most likely to use in filters. So this can be, I don't know, I feel like this can be quite simple if you've got data where you're going to be analyzing things by date. But if you've got data where actually you're going to be using different groupings, then sometimes it's easier just to use a bit of trial and error and figure out what is going to work for you and your use case. Okay, so just to summarize kind of that kind of main bit. So Arrow lets you work with larger than memory data directly from R using the dplyr API. Storing files in Parquet format will speed things up significantly. And if you are using partitioning, which I'd recommend, you should definitely partition data based on your analysis workflows. Late at night for me. So I just want to wrap up actually by just kind of pointing out some useful resources if you want to learn more about Arrow or do more with Arrow. So in our docs, we've got lots of vignettes for performing all sorts of different tasks with Arrow, and reference pages there as well. There's also the Arrow R cookbook. So the docs, the docs can be great, but I think sometimes it can be a bit dense if you just want to have a very specific task that you want to do. So we've got a cookbook that's got individual recipes for kind of performing one single thing. So it'll tell you how to achieve that task, a little bit of code and not too much detail, and then more detail further on. Okay. There's also an arrow cheat sheet if you want an overview of all the different things that you can do, just kind of in one kind of easy to kind of see in one go. Then there is an arrow cheat sheet. And also, I just want to point out actually as well, the Use R tutorial from 2022. So this was taught by Danielle Navarro, and it gives a really comprehensive overview of working with Arrow. And Danielle's got a really great site actually that has a lot of kind of text description of what kind of all of the things I mentioned, but in a lot more detail than this. So I'd recommend that. I will say that Arrow is a fast moving project. So there's a few things in there that have changed a little bit since that was originally taught. So for example, one of the things that's mentioned is that the dplyr across function doesn't work in Arrow, but it does now. But the majority of the content there is up to date and works with current Arrow. Another resource as well, I've put together this GitHub repo called Awesome Arrow, and I've just collected different resources together. So kind of whether that's talks or blog posts or slides. But yeah, the last thing is, you know, if you're interested, like, please get involved. There's lots of different ways to get involved with Arrow. So the first thing is that, like, if you find something that isn't working for you, or maybe you've got a feature that you want to request that isn't implemented, or actually, if you've just got a question about how to use Arrow, please come to the repo and open up an issue. Like, we're a project where it's a totally valid thing to, if you're just not sure about how to do something with Arrow, do feel free to open an issue, and we'll try to get that answered quickly. It's probably the quickest way, I think, to get in touch with kind of the project maintainers, and we are kind of happy to help with those. If you're interested in making, a pull request, that's great as well. So I always say, like with docs, the people that are best to write the docs are not the people that work on the package most of the time. So if there's something that doesn't make sense in the docs, or you think it could be explained better, we'd love pull requests for those. Equally, if you want to make a pull request to the cookbook, or even to the code, if there's an issue open, please go ahead. Yeah, and I think, that was everything. So thank you.
I'll do a round of applause and give you a golf clap. And other people, you can clap however you see fit in the chats. Well, thank you very much for the talk. Before we get to questions, to the R Government Conference, you can still get tickets for 20% off using code NYHackR. And for those of you that don't know, the R Government Conference is about R and friends. So R, Python, Julia, SQL, primarily in government, whether that means federal or state or local or schools, but also means public sector. So NGOs and international governments and healthcare even. So it's general public service and government of different levels. So please, folks, go hop on rstats.ai/gov and check it out. You can see previous year's videos at the same address. So we have a few questions here. So the first one is, why doesn't n-row need to be collected, but other things do? Like when you call it n-row in a data set, it gives you the answer.
Yeah, that's a good question. So with n-row, let me try to think now about the specific implementation details. I think there's things like, so basically Arrow is scanning the files in that data set. So when it scans the files, so for example, with Parquet, it's already got that information about the rows there. And it takes that kind of metadata or whatever it's scanned and uses that to calculate the rows. So it's quite a specific example with n-row compared to, say, other calculations.
Okay. All right. Then, all right. When you go to DuckDB, I saw that you're able to use dplyr, because I assume it uses dbplyr.
Yeah.
Can you actually write SQL code once it's in DuckDB, or even when it's in Arrow, I guess? But when you do to DuckDB, can you write SQL code, have that executed, and go then back to Arrow?
I think, I've not tried that myself, but I feel like maybe, because when you go to DuckDB, then you are operating on, a DuckDB object. So at that point, you can kind of do everything you would in DuckDB. I'm not sure about going back to Arrow. I think that works, but I'd have to test it out. I'm not sure, sorry.
So I guess you're saying we'd use like DBI to make the SQL queries on it?
To be honest, I've really not played with that, so I'm not sure.
Okay, fair. I do think there is a way of dplyr to pass through SQL if you're using dbplyr. There is a function. It's like SQL.
Yeah,
So
I've
maybe
seen
that
someone
works.
talk about this earlier today, but it slipped out of my memory.
Okay, well, that will be something that will haunt you now. You mentioned Parquet only stores unique values of data. It's like the word pizza is in there 1,000 times. You only store it once. Is it doing like a SQL normalization, like the fifth normal form or whatever?
I think it's more to do with like the kind of encoding that it's using, basically. I don't know how I compare that with normalization. It's I think it's basically this idea that it can just say, right, I've got this value this number of times. I forget what the encoding type's called now, but it's a very specific thing. But yeah.
There's not a question, but it's a comment that just came in talking about the SQL DF package. And that's a little bit different than what's going on here. So SQL DF allows people to write SQL code to query a data frame that's in memory.
Oh, nice.
So that's actually pretty cool. And that's been around for 12, 15 years or something. It's been around for a long time. It's pretty cool. And there's actually a newer function written that acts a little bit differently. I forget what it's called. Don't remember the name of it, but there's a new pack. So what SQL DF does, it actually pipes your data frame into a SQL-like data frame behind the scenes and shoves it back in. There is a new package which actually takes SQL and translates it to dplyr verbs and runs that on a data frame. So there's some
really
things
cool.
like that. Yeah, it is, isn't it? Yeah,
I like that. Whatever you want to use, it'll work somewhere because somebody's enabled it. That's brilliant.
Yeah, there's a lot of stuff here. It's really cool.
Nice.
All right. When Arrow writes data sets to CSVs and you do a grouping, the grouping columns don't get written into the CSV file because they're in the folder structure. Is there a way to force that to put the columns in the CSVs anyway?
I would need to double check that. I don't know off the top of my head. Like, I don't know if it works slightly differently if you use the Hive style directory. So the Hive style is just when you've got the column name equals and then the value rather than just
that's the default, right?
Value. I don't think that's default with C. Sorry, I'd have to. Hey, but if somebody wants to open up an issue, then I can totally follow that up and I will get an answer to that question. I don't know off the top of my head, sorry, right now.
If it doesn't exist, I'm putting in that feature request personally.
Okay, good. Yeah. Do it, please.
Can you do joins of Arrow?
Yes, you can, yeah. So I think we've got pretty much most of the typical kind of joins implemented in Arrow. I think the only thing to be aware of is that when you're doing joins in Arrow, it's worth looking into the concept of schemas, because when you're when Arrow converts data, say if you've got an Arrow data set and you're joining to a table that you've got or something, you've got to make sure that the join key of the column that you're joining on has got the same kind of Arrow data type. I can kind of send more information about that because it's more than a kind of 1 minute explanation, but yeah.
And if you're doing an Arrow table joined to an Arrow table, same idea, right?
Yes, exactly. Yeah. Okay. It's just going to be the same data type of the join key. Yeah.
What if one is an integer and one is a numeric? Does that work automatically, or is that still a problem?
No, because numeric is converted into, I think, into double or float. So what you'd have to do is just manually set the kind of the data type of those of the column to be the same. Otherwise, that can lead you to issues. Yeah.
Okay, so even though an integer and a character, you'd have to manually convert the integer to a numeric first. All right.
Yeah, it's all to do with the idea that Arrow's got a richer, a wider kind of list of data types than R itself. So a lot of the time when you're converting things between R and Arrow, the Arrow package does all the work for you and automatically converts it. And that will work fine in most cases, but it's just sometimes on joins that can trip you up. Yeah.
Are factors represented in Arrow datasets?
Yeah, so we've got the dictionary type in Arrow, and depending on whether you kind of like specify that as that data type when you're reading it in or not. But yeah, you can use dictionary type is roughly equivalent to factors. Yeah.
Okay, cool. This one's from me. I might have asked you this before, so if I did, I apologize. If you open a data set in like a markdown chunk and you're using caching, can you use that open data set in a different chunk later on when you're knitting?
So actually you mentioned this the other day and you promised you'd open an issue on the repo and you haven't yet, so I'm quite sad about that. But
Right.
Do you know what? I came across this myself when I was writing the slides for this and got a bit frustrated with it. I think the problem with that is an arrow object, it's not quite the same as, say, when you've got like a data frame or a tibble, and it can't just be kind of like written. An arrow object in R, it's an environment, it's an R6 object, and I think the short answer is you can use it between different chunks. That does work, because that did work when I compiled the slides for this today. But if you've got caching enabled in your Quarto document, then things go wrong, because it can't actually cache those objects, because they're kind of in arrow memory and just have a pointer to that. So the caching is what makes it go wrong, I think.
So follow-up question, would the same issue be, would there be the similar issue if you're using targets and you try to make an open data set one of the targets and then use it later on?
I'm not sure with that. I'd have to, I imagine it might, but yeah, I'd have to follow up on that one.
And then I guess follow-up. Can we serialize the open data set somehow?
How do you mean? What do you mean by that then?
I don't know. Basically, like somehow, like it knows, like if you can serialize it, then like you write to disk what it's pointing to. That way, when you pull it from disk into cache, like a special type of serialization, it knows, hey, I was pointing to these sets of folders over here.
I guess not really. I guess what you'd want to do is create a variable that either has the list of files that are in your data, because when you open a data set, you can either give it a list of files or you can give it a directory, and then it'll scan that directory. So if you were to store the name of the directory or the list of files to a variable, then you could serialize the variable that's just, you know, a character vector containing those. But the dataset object itself, I guess it wouldn't really make sense to serialize it, because it's a little bit saying, can you serialize a database connection object? And I don't think that you can, right?
No. And so in full disclosure, the way I've done this in the past, the first hacky way I did it was in my markdown chunks, anytime I was going to use that data set, I'd have a line creating it in each chunk and like say echo equals -1, and that would get rid of it. And it was horrible. And I think at one point I did, but I don't remember where, I wrote like a knitter hook that would, for a certain type of chunk type, would automatically create the connection to the data, to Arrow, to open the data set. Not as bad as doing it manually, but still not great.
Yeah. Oh, you should have like opened an issue on the repo, and we could have done all that work.
Yeah. And that, since I don't remember what I did, I should go open the issue so it can be done anyway.
Yeah. All good.
Yeah. Good luck with that. Okay. All right. Let's say you have a bunch of Parquet files. Like every day you're getting new data, putting in. Can you append the new data to existing Parquet? And if not, what do you do?
I don't think you can append to existing Parquet. I think that's I have seen a ticket open related to that, but I'd say write to a new Parquet file.
Okay.
And I guess if you're working with kind of partition data, then you've got a data set that's made of multiple Parquet files anyway, so it's probably no issue to do that.
Yeah, I guess as long as I wonder if, let's say, the new data has a bit of like if you pull in, it's hard for me to describe this, but one concern is that you have some new data but some old data, and you write to the same folder. What happens to the existing? Let's say you're partitioning by date. You get new data of the original date. Does that override the old date Parquet file? What happens there?
I think you'll end up overwriting it, but there is a setting actually. It's one of the kind of more advanced settings, but there is a setting where you can specify whether you overwrite existing files or not, or cause like end up with an error with that. I could find that setting somewhere in the docs. But yeah, it's possible to kind of manually control that. Yeah.
All right. I'm not sure if this is your field or not, but what is the state of geodata in Arrow? And can we use like the SF functions on an Arrow table if it has a geometry column?
Oh, do you know what? I really should know this, because my colleague Dewey like works on a lot of this stuff, and I feel terrible now that I can't describe the stuff that he and other people are working on really well. But I'm not super familiar with the GeoArrow stuff. Sorry.
Right,
but there is lots of geo-related functionality, and I would recommend just looking up Dewey Dunnington, and he's not the only one, but he's the person that I know, and then that will lead to that work.
I guess we need to get Dewey to speak soon then, right?
Yeah, definitely.
So Dewey, if you're watching this live or recording, you're up soon, buddy. Awesome. All right. So can you comment on where polars fits into all of this?
Well, I know obviously you can get kind of like similar kind of things with polars in terms of working with kind of large data sets. I know there's an R package related to kind of working with that from R. I think I don't want to comment about other projects. I think there's a lot of tricky things at the moment, just kind of getting Rust packages on CRAN is tricky and it's new and there's lots of difficulties around that. But Polars is great as well. Like, you know, there's a lot of kind of similar functionality in there. So yeah.
So I guess from an R user or even a Python user, because I know Polars is richer and is more wide adopted in Python because they don't have this great dplyr Arrow integration. Like, what is it, like a competitor to Arrow / dplyr, or like, what is it?
I don't know. It's hard to place things right because these different packages have different kind of functionality. To be honest, I haven't explored its full functionality. Like, I think there is a dplyr API package for that somewhere. There is some functionality for that.
For Polars?
I think so. Yeah, I need to. There's so many different packages at the moment that are doing kind of a lot around this. It's hard to keep up, I think.
We see a comment here. It says there's apparently a package called parquetize, which has a function called parquetize, which converts large SAS and Stata files to Parquet. That sounds really cool.
Yeah, that's cool. Actually, I've seen that package, and it kind of wraps around like a lot of kind of the Arrow functionality, but like has slightly different convenience functions for kind of more kind of it wraps around more of the workflow. So, but I didn't know it worked with SAS and Stata files. So that's pretty cool. Yeah.
And I wonder if that it's sometimes hard to get data out of Postgres or SQL Server into Parquet. So I wonder if there's something similar. In the past, I've had to use like DuckDB to rip it out of Postgres quickly into a Parquet file. It'd be really cool if there's something like that that goes straight, and especially SQL Server, since so much of the corporate world is in SQL Server. But,
yeah,
I know that's not your area, but this was a cool comment there.
Nice.
Yeah, and then I think I'll give everyone one last chance to ask questions here and see if there's anything else, if anyone has anything else they want to ask here about Arrow or about anything else. If not, I'll give a few announcements. Well, just one announcement in the meantime. Remember, folks, September 27th, in person and virtual, we'll have our next meetup, predicting Taylor Swift songs. That will be really, really cool. That's Eli Miller is going to do that. And then again, if you have space, let us know and have the space. There is a question. Is your code on Git for the presentation, I presume?
Yes, it is. Yeah, I've got it all in a repo. I've sent it to Nicole, who I think said she'll get that sent out. So yeah, all the code that you'd need to replicate any of the stuff that I've shown today is all in that presentation in the repo.
All right, wonderful. All right, then I'll put one more question to you, closing out. What do you see the future of Arrow in the R community being over the next 12 months, let's say?
Oh, that's a good question. Do you know what? It's a tricky one to figure out because there's just been so many bits and pieces going on. I think we've got to a point where a lot of our kind of dplyr bindings are pretty stable now. You know, and anytime things update in dplyr, we do try to kind of then pull that functionality kind of into Arrow. I mean, I'd love to see, we've got a lot of string R and lubridate kind of bindings. I'd love to see more of those to fill like the little bits and pieces of the gaps that we don't have. The Azure stuff is quite interesting. So some people are working on being able to work directly with data in Azure. So that's going to be, I'd be really excited to see more cloud stuff done, basically. And other than that, I've had some personal projects I've been working on, just things like kind of reshaping our docs just to make things a little bit more approachable. So lots of little bits and pieces like that going on at the moment.
I do believe I asked either Neil or Jonathan to support Azure like a year ago, so I'm very excited that will be happening.
Nice.
Yeah. All right, great. Well, I think that is everything. I want to say thank you very much for this talk. I think everyone should be using Arrow more if they're not using it already. I'm a big fan of it. And everyone else, remember, next month, in person and virtual, and we have the R and Gov conference coming up. And if anyone ever wants to give a talk, let me know. That's how these things work. So a big round of applause to Nick, everybody. Thank you very much for being here.
Yeah, thanks for inviting me. It's been really great. Cheers.
Great. Have a good night, everybody.